difficulty, but we'll see. So we'll start with the first one. So relative to the origin, very important why you have the things as OA plus OB plus OC and OD, the fact that you are given vectors like this. This is what you should know. If we say vector AB, vector AB is the same as OB, the second point minus the first.
Yes.
You get it? Are we together?
Yes.
Yes, sir.
Yes.
So this is what we're referring to as the displacement vector. So if you have to go from O to A, O to B, let me say I have it like this. I want to go from AB. So that is basically, think of it as this direction here. So in order to do that, can you see that you are going against this arrow? So it's minus OA, and then you're going along AB. Can you see that? So that's why we say it's the second point, the position vector. So yeah, when you say position vector, we always start with O, right? Position vectors are written in terms of O. So it's OB, the second point, minus the position vector of the first point. So for us to find AB, because first they are saying we should show that AB is perpendicular to BC. Are we together so far? So we need to know what AB is, and we also need to know what BC is. So using this, AB would be OB, which is 2, -3, 5, and minus OA, which is given to us as -1, 3, and -4. So you'll just be subtracting those components inside. So 2 minus -1 is 3. -3 minus that is -6. 5 minus that is 9. Are we following?
Yes.
So what I've done there effectively was vector AB. Now let's do the same for vector BC. Remember, BC would be the position vector of the second minus the position vector of the first.
Yes, sir.
Now you can go back. OC, you see it's 4. What is OC? It's 4, -2, 5.
5.
And OB, 2, -3,
-3.
and 5. So you'll take those values together. So you say 4 minus 2, well, that is just going to be 2. -2 minus that is going to be +1. Just make sure that you don't make a mistake. And 5 minus 5 is 0. Are we clear? Okay, so now we have AB and we also have BC. Now, in order for us to show that these two vectors, these two are perpendicular, right? Basically, it's this concept here to show that they are perpendicular. There is something known as the dot product. Okay, so the dot product, this is what I'm going to do in tomorrow's lesson. So in order for you to find the dot product, basically AB times BC should give you 0. If you multiply these two, they should give you 0. Okay? So let us see if we do that. So you're just going to multiply the components with each other. Remember, I wrote down AB. AB was 3, -6, 9. Dotted with, remember AB is all the way up here. 3, -6, 9. Dotted with BC, which is what I have here, 2, 1, 0. So that's 2, 1, 0. So let's see if we multiply whether it gives us that. So 3 times 2 is 6. Are we together? Plus -6 times 1 is -6. Plus 9 times 0 is 0. So in fact, when you are multiplying, you get 0. And if you get an answer of 0, it means that those two vectors are therefore perpendicular. Dot product. Okay, so we just take the first part of it. Are we together so far?
Yes.
Okay, so part 2, we have to show that this is a trapezium. Now, in order for us to show that this is a trapezium, this is what we need to consider. The formula to calculate the area of a trapezium is whatever the magnitude, the distance of DC, or I can even say AB plus DC times the height, and the height being what?
C.
BC.
BC.
So I have to find the magnitude of AB, the magnitude of DC, and the magnitude of BC. Then I will sort of substitute it into that formula. Right. So let's go back and let's find the magnitude of AB. Now remember, AB from our previous work was 3, -6, 9. And the magnitude, the modulus, the magnitude of that, you just take Pythagoras, né? So you just say 3 squared plus -6 squared
-6
plus 9 squared. You take the square root of everything. So it will be the square root of 126. Then we need to do DC as well. Now DC, we know from our previous work. What is DC? In fact, I need to come back to yes. Are you together with me?
Yes.
Okay. So I'm doing Roman 2 or Roman 3. I was now doing Roman 3, man.
Meneer moet show.
Yes, we have to show that it's a trapezium. In fact, can I come back to that showing?
Yes.
Okay, because I already started with part 3, né? I'll come back to showing. So this is part 3. I'll come back to showing that it's a trapezium. So DC, if we have to calculate DC, remember DC is OC minus OD. Okay, what is OC?
4
4, -2, 5. What is OD?
2, -1.
2, 2, -1. And if you calculate this, you're going to get what? 2, 0. You get 0. Okay.
0.
-2 minus 2.
0.
It's -4. And 5 minus -1 is what? 6. Are we together? Okay, so we can calculate the magnitude now. So the magnitude will be 2 squared, -4 squared, 6 squared. If you punch that on your calculator, what do you get? Square root of 56. Are you getting square root of 56? Takes you long enough.
Yes. 7.
Okay. Let me just add a page here. We just add a page. The next one that we are supposed to calculate is BC. We have BC already?
Yeah, I can say BC.
Yes.
What is BC?
210.
210. Now we have the magnitude of BC would be, again, Pythagoras. So it's 2 squared plus 1 squared. Of course, 0 squared is just 0. If you work this out, you get nothing but the square root of 5. So now I have my 3 measurements.
Now we find the area.
So the area would be half times AB, okay, plus DC multiply that by BC.
CD, BC.
Are we together?
Yes.
So it's 0.5 in bracket AB, that was the square root of 126
Yes.
plus the square root of 56,
Yes.
multiply that by the square root of
Multiply.
5.
Mhm.
So punch that in on your calculator and give me the answer to 2 decimal places. $20. Are you not getting
20.9
0.92, 2 decimal places, yeah?
or 92, yeah.
Okay. There is just one more thing. When they were asking us to show that this is a trapezium, for us to show that that is a trapezium, this is basically the only thing we need to do. Roman 2, I'll just write it here. We have to show that DC is a multiple of AB. Yes? What was vector DC? Because we have done it, did we?
2 minus 4, 6.
2 minus 4, 6. Can we take out a common factor or a scalar quantity there? What goes in all of these components?
2.
2.
So 2, that will leave me with 1, negative 2, and 3. Am I okay?
Yes.
Yes.
Now let's find out what is the one for AB. What is AB? We have done it before.
It's 3 minus 6, 9.
Can you take out a scalar quantity,
Yes.
which
3.
is 3, and then you're going to be left with the same thing.
1
Yeah.
minus 2. 3. Yes.
Yeah? So the stuff in the middle,
Mm-hmm.
the stuff here is what gives us this definition. Okay?
Mhm.
So once that stuff is in the middle, is like that, now you can say, therefore, DC is, they are parallel to each other. It's a parallelogram because those two are parallel. So this is just a scalar quantity, how long that is. Is it clear?
Yes, sir.
Yes, sir.
Yeah. So when we have a k, when we have a constant here, sometimes we use what symbol is that? Physics. What symbol is that?
Lambda.
Lambda. So we can be saying that you have vector A. You can say vector A is multiplied with some scalar quantity of vector B. Then these two vectors are parallel.
Mm-hmm.
That's basically what we are looking at. Okay. I want you to go to the one on page in your textbook before we continue. Okay? I want you to go to the one in your textbook, page 244. This one.
Mm-hmm.
Are you there?
Yes.
Yes.
Okay. So again, as I said, I will be explaining some of these unit vectors and displacement vectors, position vectors. As I'm continuing, you are going to pick up on position vectors and so on. So you have information there. It says the diagram shows a solid cylinder standing on a horizontal circular base, which means that it's flat. It's on a flat surface. Okay. So it's upright then. Center O, radius is 4 units. Line BA is the diameter, as you can see. Radius is OC. And they are all at 90 degrees. OA. Can you see that? To OA, OA to OC. Because it's flat,
Yes.
that's 90 degrees, so it will be also from OA to O prime, that little prime that you see up there. So when you have things given to you of I, J, and K, what are they called? What are they called? Base vectors. Which letter is first?
I.
Followed by?
J.
J.
Then by K. So when you write it
Yeah.
in terms of when you write it as a vector form, this is what you're going to do. So your X, your Y, and your Z. Is that fine?
Mm-hmm. Yes, sir.
Okay. Let's then see if you're getting it. Just want to welcome, ma'am. How are you? Welcome, ma'am. How are you? We have to unmute also. It's not easy. Linda, did you mute?
Yes, I muted myself.
Okay. All right, let's continue while she's trying to unmute. Okay. All right, anyway, when they are saying express vector MO and MC in terms of that, so let us find MO. So what I'm going to do is I'm going to draw a line from M to O like so. Can you see that?
Mm-hmm.
Right, so what we are going to do is we are trying to see how do we then move from M to O. So MO would be MB, can you see that? Plus BO, do you agree?
Yes.
Okay, so since the distance from A prime to A is 12, it implies that this is also 6, but you can see this is in terms of what? Of K.
Okay. Yes.
So this is 6K. So
Okay.
if you go from M to B, it's positive 6K. Is it positive or negative 6K?
Positive.
Is it positive? Are you sure?
Yes.
MO, sorry. I'm doing the second one. Can you see that I'm doing the second one? Let me just start over here, okay? Let me start over here. And I'm going to remove this line. Are you fine?
Yes, sir.
Okay, so M to O is this distance. Can you see that?
Yeah.
Yes. So that is MB plus, you agree?
Yeah.
It's from here to there. Can you see that you are going against this 12, no?
Yes.
Okay, so it will be minus 6K. Now you are supposed to do something like this, a little squiggly thing underneath it. Some people, they put like a little head thing on top of it because you are not writing in bold now. What is the radius? We are told the radius is something. What is the radius? So the radius from O, the radius is just 4,
4 units.
right?
Yes.
4 what? 4 in which direction?
From O to C.
So BO is the same as O to A. You agree?
Mm-hmm.
So this is the same then as for I. Are we together so far?
Yes.
So there's no, so now you have to write it in terms of, you have to start with the first letter, which is what?
I.
So it will therefore be 4i plus 0j, you agree?
Mm-hmm.
Minus 6k. That's how you must write it. You don't have to write the 0j there, but I'm just writing it anyway.
Yes.
Okay. The next one they want us to find is M to C. So it's from here to C prime. Are we there? Are you following?
Yes, sir.
So to go from M to C, so I have, my God, let me just, MC would be MB, but B dash B prime. That means I'm going from here
Yes.
all the way up to there. Then I'm going from B dash to O dash. Can you see that? Or B prime to, so I'll go B prime to O prime. And then I'm going to go
Yes.
O prime
From
to
O
C
prime.
prime. You get it?
Yes.
Okay. O prime to C prime. So going from M to B, is it going to be positive? You agree? So that is what?
6k.
6k. Going from B prime to O prime is the same as going from B to O or O to A, which is
4i.
4i. Going from O to C, now you must be very careful. O to C is also the same as the radius, right? Yeah? The distance will also be 4. For
Yes.
what? For what?
4j.
For J. But now we just have to write it correctly. Which one comes first?
For I.
4i followed by?
For J.
Followed by 4j. And then obviously
6k.
6k.
Yes.
That's what you have, right? We're together?
Yes, sir.
Yes.
All right. Now part B says we have to find the angle. So basically it's this angle here. So I'll call it theta. So to find that angle, again, you have to think of the dot product, which is I'm going to go immensely in tomorrow. We're running out of time, okay? So let's see. So to find that angle there, so we first have to determine what is MO. What is MO? We have calculated before. Could you tell me? Now give it to me as a vector.
4, 0, 6, -6.
So it's 4, 0, -6. You agree?
Yes, sir.
We also need to know what is MC prime, which is that distance there. We have almost worked it out.
Yes.
Sorry, this is supposed to be
4,
MC prime. There. 4, 4, 6. Am I correct?
Yes.
So it's 4, 4, 6. Now that we have that, we also need to do a few things. We also need to calculate the magnitude. Let's make this a little bit thinner. So let's find the magnitude of MO and as well as the magnitude of MC prime. So the magnitude of MO would be square root of 16, that's 4 squared, plus 0, 0 squared, plus 36. 36 comes from -6 times -6. We're together?
Yes.
So this gives us a square root of 52. Then MC prime, again, is 4 squared, which is 16, plus another 16, plus 36. And what does that give me? Square root of 68. We got it?
Yes.
Yes, sir.
Okay. Now the dot product means you are going to take these two vectors, you're going to multiply them. So you're going to dot 4, 0, negative 6 will be dotted with 4, 4, 6. That should equal to the magnitude of M to O times the magnitude of M to C times the cos of the angle.
Is it the MC prime?
MC prime. Okay, we can do this one. 4 times 4 is what?
16.
0 times 4 is 0.
0.
And this is going to be
Minus
negative
36.
Negative.
36 now. And we know that that one was the square root of 52. And the other one was the square root of 68 cos theta.
Mm-hmm. Mm-hmm.
We are getting so far. So this gives us 20 over here. And you can multiply the numbers in there. You can say 52 times
It's not
square root.
negative 4.
Minus 20.
It's minus 20 is correct.
Mm.
So basically that minus 20 has to be divided.
Like that.
Okay, so let's insert a page quickly. No, insert a page. My God, it's not where I wanted it. Insert page. What did I say? Append page. Okay. So that leaves me with cos theta, or that angle will be negative 20 divided by the square root of this horrible number. What is it? 3536.
And you do inverse of that is 109.65.
Okay. Let me just allow someone in. The inverse of that is what?
109.65.
Okay, the inverse is 109.65. So you have the inverse of that answer, and you say 109, no, 109 degrees, 109.7 degrees, maybe to 1 decimal place.
Yeah.
Yes.
Okay, so that's how you find. So obviously there's a few things that you have to get used to. They are things like, what is it? The dot product. So we are going to go in depth tomorrow into that. But there is also the way we're going to derive that is by using the cosine rule. But as long as you have that and you have your formula sheet, you should not have a problem with that. I just want to go to a question paper. In your question papers at the end of the year, in your list of formula and notation, all right, for vectors, you have your dot product. Can you see that?
Yes.
So we're going to show you, basically that's what we've been using so far when I was multiplying our two vectors. Do I still need to do something here or go back? Okay. Let's go to the next one. Who's laughing there at the background?
Natalia, mute your mic, man.
And she's laughing at it.
What? Are you it's my sister?
I want you to go to page 9. I'll be sending a Dangasas very soon. Another link because we don't have much time. We have 2 minutes left. I want to do this one, the one of 2015.
Yeah.
Okay. So I'll be sending a link very soon. So basically, they want us to find. They say the cosine. They don't want the angle. They say the cosine of the angle. All right. So I'll send you a link. So I'll end this meeting and then I'll send you a new link. Is it fine?
Yes.
Okay.
People leave. Your money. What? Please, you should go.